Here now is your host and moderator, Milton Rosenberg.
One of the great cliches when you're introducing somebody is to say, here's a man who needs no introduction. And I don't say that more than once or twice a year, but it's certainly appropriate tonight because our guest is Carl Sagan. And as they say, enough said. However, I offer to Carl Sagan, who is the author of the new book, Pale Blue Dot, A Vision of the Human Future in Space, two quotations. This is a trick that I sometimes play, Carl, and you can take your choice of which one you think is the appropriate epigraph for our conversation tonight. The first is a quotation I'm sure you're familiar with from E.E. Cummings. Listen, there's a hell of a good universe next door. Let's go. And the second is from Peter Cook, one of the British comics who did Beyond the Fringe years ago, who says, I'm very interested in the universe, and I'm specializing in the universe and all that surrounds it. Which do you choose?
Well, I like both of them, but I would say the first one is a lot closer to what Pale Blue Dot is about.
It is indeed. You say that man is a wanderer, and that you say there is a hell of a good universe, and also a necessary universe next door. Let's get ready to go because we are going, and you predict a good deal about what the nature of our venture out into the universe will be.
Yeah, the basic argument there is that we've talked about this before. I wouldn't say man, I'd say humans. Because it is in both genders. But we are wanderers. I mean, humans, our species is a few 100,000 years old. Our genus, the genus Homo, the human family, if you like, is a few million years old. We've had civilization only for the last 8,000 or 10,000 years. So we're wanderers who have hit upon a brief sedentary hiatus. And the wish to wander, to follow the game, has to be built powerfully in us, because millions of years is enough for genetic propensities to be established.
And so thinking in Darwinian terms, we are naturally wanderers because wandering was the trait in us that nature selected, and it selected it because the wanderers were the ones who survived.
That's right, who followed the game, who came to the trees when they were in fruit or nuts, and that was how we, before agriculture, that's how we lived. And there's, words like wanderlust, which convey something of that. But the earth is all explored. There's nowhere else to go, and we're sedentary and don't go anywhere. And a lot of people feel, I think a lot of people, maybe more men than women, feel it as a kind of itch, vague discontent about not going. And that's why sports and war and occasional exploration and adventure really are very attractive.
But it shows in our ordinary lives as well. We still remain wanderers. I'm sure that you, who are much in demand, I know, around the country and around the world, you have two invitations, one for a very interesting conference in Cleveland, and another for a possibly less interesting conference in Bucharest. You'll probably go to Bucharest.
It depends whether I've been to Cleveland before, but yes, of course you're right. It affects all aspects of our being, and the Earth is all explored except for the ocean bottoms. There's no place to go. But at just this moment, exactly the technology that has permitted us to explore the Earth now is on the verge of permitting us to go to other worlds. We live, as your quote from E.E. Cummings says, in a hell of a solar system. It is glorious, magnificent, with 9 planets, some 70-odd very different, very interesting moons, tens of thousands of asteroids, trillions of comets, and no two of them exactly alike, with all sorts of things about origins to learn from them, origin of our world, origin of ourselves, and some of them we can foresee the ability for us to live on, to have self-sustaining communities on.
The French, when they were investigating, or rather colonizing, or at least examining North America in the early 17th century, perhaps even earlier, the men that they sent up and down the rivers of Middle America and Canada and so on were known as les voyageurs,
right,
the voyagers.
Right.
And it seems to me that we've had voyageurs certainly in our time. most of it, we haven't yet settled any other planet, but surely in our time, and you've had a good deal to do with the construction of this aspect of our time, we've sent voyageurs out into space. They've landed on at least one other significant stellar body, so to speak, or planetary body, namely the moon. And you've been involved with the Jet Propulsion Laboratory people in sending explorers of various kinds, mechanical explorers, but loaded with equipment designed by human beings to explore all the planets of the solar system. So we are already launched on our extraterrestrial extension, are we not?
You're completely right. And in fact, two of the most successful robotic explorers were called Voyager.
Yes, they
Voyager
were
1
indeed.
and Voyager 2. And in fact, it is Voyager 1 that took the distant picture of the Earth as a pale blue dot, which gives the book its title, Pale Blue
And
Dot.
I learned from this book, I didn't know the story behind this, that it was you who sort of pressed to get the valuable time of the camera and of the total equipment so as to take that picture. Some of the other people, particularly the government people, didn't want to bother utilizing their equipment to merely take a picture of the Earth.
It wasn't essential science, but it seemed to me that the perspective of seeing the Earth as a dot from beyond the outermost planet was worth something, and to me at least it is so poignant and beautiful and speaks of the vulnerability and fragility of our planet that I'm really so happy we were able to take that
So
picture.
that little pale blue dot is really virtually lost in space, and the space is so vast that we still have trouble comprehending it. It would be worthwhile once again reviewing for our listeners the extent of the known universe.
Okay, let's do that in a minute. So we live on the Earth, which is a quite small world, not nearly as big as Jupiter, Saturn, Uranus, and Neptune. In that panoply of other worlds I just described, orbiting a quite humdrum sun, which is in the third or fourth spiral arm out from the center of the Milky Way galaxy, which is a collection of some 400 billion stars.
There's that famous word that you've been stuck with. Billion, not million, but billion with a B.
Did not invent it. The universe invented it.
Yeah.
And this galaxy of 400 billion stars is just one of about 100 billion galaxies. And beyond that, there is now a view, respectable but not demonstrated, that our universe is one of a huge number, perhaps an infinite number, of other mutually closed-off universes.
That's the most exciting thought. I've heard it before, of course. I don't comprehend what it really means or the science or the theory by which the notion is generated, but when I first heard this kind of speculation from David Schramm, in fact, who's a colleague of mine at the University of Chicago, it stunned me that there are possibly an infinite supply of universes contiguous to ours but unreachable.
That's right.
From ours to theirs.
Well said, Milton. So, in light of these enormous numbers, possibly literally infinite, but if not, I mean, never mind the other universes. Just think of, 100 billion stars in a galaxy, 100 billion galaxies. In that perspective, now consider the human conceit that we are at the center of the universe, or worse, that we are the reason there is a universe. Now, this is something which is a transcultural delusion for most of human history. Almost everybody believes.
And in this book, and not for the first time, your mind and your speculation turns to what religion makes of our situation in ultimate reality. You suggest that there is a tremendous anthropomorphism reflected in our religions, and that our God, to be so focused upon us, cannot be a proper representation of God. But perhaps if God is there, whatever God ultimately is, perhaps God is interested in organic life, and perhaps he's done the same for all other modes of being that you may find elsewhere, distributed not only in the near reaches of the Milky Way galaxy, but throughout all of this universe, perhaps throughout all the universes.
An omnipotent, omniscient God could be very busy dealing with life on all those conceivable abodes of life, that's certainly right. But that's a could. That's a speculation. And the question is, first of all, what do we mean by God? And secondly, what is the evidence for whichever kind of God you are talking about? So let me just, for clarity, give two end members of a continuum of possibilities of what people mean when they talk about God. One end of the continuum is the idea of a large male human with light skin and a long beard that sits in a throne in the sky and tallies the fall of every sparrow, makes the morning glories open, and does micro-intervention in human history.
This is the God on the ceiling of the Sistine Chapel, in fact.
Yes. Now, for that God, I know of absolutely no evidence.
No.
I don't say no. Maybe the throne is where no one's looked. But there is no evidence for such a God, and it seems such a patent reflection of our own hopes and fears and the kinds of political systems, I'm talking about kings, that we used to have. At the other end of the spectrum is the kind of God that Einstein talked about, or Benedict Spinoza, which is very close to the sum total of the laws of nature. Now, there are laws of nature. It'd be foolish to deny it. And what's more, it needn't have been this way. The laws of nature that apply here apply 10 billion light years away, the same laws of gravity, the same laws of quantum mechanics. So there certainly are universal laws of nature. If that's what you mean by God, then of course God exists. Now, this latter kind of God is a little difficult to pray to. I wish now to pray to the Newtonian gravitational constant. It's not satisfying.
It's easier to praise him or to praise that God than to pray to that God.
Yes, because the
praise rather than prayer.
The order that those laws of nature induce in the universe is magnificent, elegant, subtle. So this issue of God, many people are quite happy to put the question, do you believe in God, and then take a yes or no answer. Mm-hmm. You've learned absolutely nothing. The question is, what kind of God is being discussed?
Within that large universal or cosmic order, created by or presided over by God or not, as the case may be, we can put that question aside because surely we will not resolve it here tonight.
Quite right.
But within that cosmic order, there is that interesting species, Homo sapiens sapiens, and it is likely, and it is the voyageur species, it has already gone beyond this planet, it is likely to, ultimately, you feel, that is not ultimately, but in conceivable forward time, it is likely to begin to stretch out into the universe and try to populate other places. The first place we would populate, I suppose, is the moon, or rather at least establish stations on the moon, would we not?
To my mind, the right first target is near-Earth asteroids, for a number of reasons. For one thing, some of them are even easier to get to than the moon. They take less rocket prowess.
Which are they?
For example, first of all, there's hundreds of them that we know, and there's thousands of them that we don't. Reasonably sized ones. But for example, there's one called Nereus, Nereus, which is very easy to get to. The only downside is if there was something that went wrong, it would be hard to get back to the Earth quickly. But easy to get to, easy to get off. The gravity is much lower than the moon even, say, so you can get back much more easily. And these objects are of interest for a number of reasons. One is that an entrancing number of them seem to be double. Two worlds in sort of grazing contact. And that looks, to some of us, very much as if we are seeing the process by which worlds are built. The gluing together of smaller worlds into bigger ones. And that's something very important. How did the Earth form?
How close is Nereus?
I don't have it in my head, but at its closest, it is a small fraction of an astronomical unit being the distance from the Earth to the Sun.
Yeah. And what is its volume? How large
the
place
bulk
is it?
of these worlds are kilometers across or smaller. 10 kilometers is a big one.
Interesting you call them worlds rather than...
Or worldlets.
Worldlets, yes. Diminutive worlds.
Diminutive. And another interesting thing, just parenthetically, is because the gravity is so low, You could do a standing broad jump 10 miles into the sky, or you could throw a baseball into orbit. In fact, you could do a game of baseball all by yourself. Pitch the ball sidearm, parallel to the surface. It'll then go around the world, then pick up your bat, and half an hour later stand in the opposite direction, hit the ball, and then go racing after it.
I'm suddenly having a memory of, and this is kind of a metaphor for what we're not talking about, of our waging the Pacific Campaign during World War II. It was called the Island Hopping Campaign. To ultimately get to the Japanese mainland, we had to knock out the Japanese in some particular location, establish airfields on one or another island and one or another Pacific archipelago, and ultimately we would get to our goal. The goal was merely Japan. And in fact, we got there by dropping the nuclear bomb, or then the atomic bomb, which short-circuited and short-cut the whole process. But here we've got a kind of world hopping.
Absolutely.
Well, what's the course? If you were at Cosmos Command Central, what would the likely course be that you would plot out? Indeed, you do plot it out in the new book, Pale Blue Dot. We go first to where, then to where, then to where, and how.
The thing is, Milton, that we have not yet inventoried the near-Earth worldlets. We don't know where all of them are. We only know statistically there have to be so many at the rate at which we're discovering new ones and so on. So nobody can plot that out. There may be still undiscovered asteroids and comets that are the perfect objective to go to. But generally speaking, I think, and putting the moon aside, I'll come back to why we should put it aside later if you like, I think the near-Earth asteroids and then Mars are the obvious short-term goals. Let me say one other thing about the near-Earth asteroids. It's not just that we're going to learn a lot from them. It's not just that you can break Olympic records on them. The average person could. It's that they pose a serious danger to the Earth. And that is, wait long enough and a near-Earth asteroid or a comet is going to hit the Earth.
As they have done in the past.
As they have done in the past. Now the thing is, there's a lot more little ones than big ones. So a little one hits the Earth, burns up in the atmosphere, doesn't do much damage. But on the other hand, 65 million years ago, the Earth was hit by a 10-kilometer diameter comet or asteroid, and that rendered extinct all the dinosaurs and 75% of the other species of life.
And if it happened again, it would render
absolutely. We are more
extinct the human race.
We are more vulnerable than most species because of our reliance on agriculture, which is a very, very delicate flower, so to say. So wait long enough. You don't have to wait for a 10-kilometer guy. A 1-kilometer asteroid hitting the Earth, of which there are many, many more, looks to be enough to do it. And this last summer, we saw a succession of 1-kilometer objects impact the planet Jupiter. And they made blemishes, dark blemishes in the clouds of Jupiter that were roughly Earth-sized.
And if we get a foothold on some of these asteroids, we're then in a position to control their movement.
That's right. Or we don't even have to have a foothold on them if we are just out there competently in nearby space and find
we can deflect
an offending asteroid we can deflect.
By what technology, in fact?
Now we are at the latest in a long succession of double-edged swords that modern technology provides. I mean, we still haven't mastered fire, and we've had it for more than 1 million years. We have fire departments because we still can't handle it. The easiest way with existing technology of deflecting a near-Earth asteroid is with nuclear weapons.
Shades of Teller.
This is a most peculiar situation because Edward Teller and I have been on the opposite sides of the barricades on so many issues, Star Wars, nuclear winter.
But he always saw the nuclear weapon, or the nuclear bomb, as an engineering device, among other things.
My view is that Dr. Teller, having played a significant role in the development of thermonuclear weapons, has spent the rest of his life trying to show that they really are good. And now here's an opportunity to hitch nuclear weapons to the Save the Earth bandwagon. And so, in a certain sense, I find myself on the same side of the barricades with him, and the irony of this has not been lost on either of us. Clearly, in an age when the Cold War is over, the Soviet Union has collapsed, the nuclear arsenals are in steep decline, the weapons designers are looking anxiously for a way to stay in business, job security for weapons designers. And now the designers, East and West, American and Russian, have a common solution when they support each other on this, and that is to use nuclear weapons to deflect asteroids.
Fascinating angle. And this, of course, is much more fully developed in Pale Blue Dot, but we have to rush on to the rest of the universe. And we'll take the next step beyond those asteroids, where conveniently we will be parked so as to protect the Earth from great asteroid-based explosions and devastations. We'll take that next step right after we pause for these words.
Have you been looking for the number to call to name a star for someone this holiday season? It's a fun and unique way to symbolize your love or friendship. For just $45 plus shipping and handling, International Star Registry will name a star for anyone on your gift list. Call 800-282-3333 to name a star in the sky. You'll get the exclusive International Star Registry gift package, which includes a beautiful full-color parchment certificate inscribed in hand calligraphy and ideal for framing, plus sky charts to help you locate the star and an informative booklet about astronomy. The new star name will be copyrighted along with its telescopic coordinates in the book, Your Place in the Cosmos, Volume 4, and stored in the International Star Registry's Swiss Vault. Call today to name a star. Give the gift of a lifetime for $45. 800-282-3333. International Star Registry. Call toll-free 800-282-3333. From Radio 720 WGN Chicago, you're listening to Extension 720. Once again, your host and moderator, Milton Rosenberg.
And just with regard to that last commercial, one really can't resist taking the special opportunity. The American Astronomical Society. No, who did it? Who named?
The International Astronomical Union gets it.
International Astronomical Union names asteroids and other bodies out in space, and they've named asteroid 2709 Sagan. That's its official name. But this thing that we've just been hearing about, which is a commercial that's carried every year at around this time, because it's sort of a Christmas gift, the International Star Registry, I think they call it.
Yes.
And if you pay $25, you get them to name something someplace out in space for the person that you designate, and it's in a book that they will it's in a book that they've got in a Swiss vault.
Excellent place to keep it. This is a complete scam.
One doesn't ordinarily knock commercials, but I'll probably get in great trouble on this, but I have to invite you to respond.
It's a scam. First of all, this has no official anything. It's just, if you want this company to name a star after you, then it's between you and the company. But it has nothing to do with astronomers. It has nothing to do with what people in the future will call
But they don't claim
stars.
that it does.
And not just that. Yeah. All the stars that we know of already have designations. They must, because how would astronomers refer to them if they didn't? Was no way to talk about them. So this is one of the many money-grubbing ways that emerge around Christmas time all around us.
I mentioned this to somebody who knows the people who run this outfit, and they said, yeah, well, they know all of that, and they don't promise anything that isn't true. They say they will give it a name, and they'll deposit it in their Swiss bank
But there is an implication that it's much more than it is.
Whereas asteroid 2709 Sagan is known as the Sagan asteroid for all time, and it's known that way.
Well, I mean, I didn't ask for it to be named after me, but
no, but it's an honor that you publicly receive.
And I'm very grateful.
Though, of course, if you're living on some planet revolving around some sun in Andromeda, and you know of the same asteroid, you don't call it Sagan.
If you're an extraterrestrial, you have quite a different set of designations, of course.
Now then, how do we become we ourselves become extraterrestrials? So far, we've only got to the asteroids. Where do we go from there, and why?
Well, there's another reason why I think in the long term it's important for humans to be out in space, and that has to do with the fact that our technology has now reached formidable, maybe even awesome proportions, so that we are a danger to ourselves. Through nuclear war, or global warming, or depleting the ozone layer, or something that we are not smart enough to figure out, but we'll discover to our amazement and horror next week, we are a danger. And we live in an environment which is very fragile. The Earth's atmosphere is extremely thin compared to the size of the Earth. the thickness of our atmosphere is about the same as the thickness of the coat of shellac on a big schoolroom globe. There's not much of it. And the ozone layer, brought down to the pressure and temperature of this room, is 3 millimeters thick, the thickness of a well-cropped fingernail. So there's not much of it there. We're messing around with powerful technology in ways that we don't fully understand. We're not very good at long-term thinking. I don't propose.
Are you suggesting that long before the sun burns out, we may render this planet essentially uninhabitable?
There is a possibility. I don't suggest that the Earth is a disposable planet. In any case, we could not possibly launch any significant fraction of the human species into space. There are 250,000 more of us born than die every day. But it seems to me that it's good to take out an insurance policy, diversify our portfolio.
That means planting human colonies elsewhere.
Don't put all our eggs in one basket, almost literally. Yes, so self-sustaining human colonies elsewhere would be an insurance policy for the long-term survival.
Where's the first one that we can establish, and
Near-Earth
when
asteroid.
can we do it?
You can dig them out. You can make habitats there. You can also make kind of domed cities virtually anywhere. Venus is too hot, but any of the asteroids. And Mars, which is a world of absolute wonders, glorious place, and which, by the way, has one extremely interesting feature, and that is that 4 billion years ago, exactly at the time the origin of life was happening on the Earth, rivers were running on Mars. Mars was an Earth-like environment with liquid water. There's no liquid water on Mars today. We don't know, by the way, what caused that climatic change. And the fact that an Earth-like world can wind up in such an inhospitable environment is very useful.
It's a cautionary lesson.
Cautionary tale. Yeah. But Mars has lots of stuff that's exciting. But the point is that if it was an Earth-like environment 4 billion years ago, and life arose on the Earth 4 billion years ago, there is a chance that life arose on Mars 4 billion years ago. And whether it's hung on in an occasional oases subsurface or something, or whether it was rendered extinct and the fossils, morphological or chemical, are waiting there for us, we don't know. But this is a very important issue. But in any case, Mars is a good place.
Wasn't there some ambiguity in the Mars lander of some
Viking results?
It was generally said that, well, the results show there is no evidence of biological material, organic material on Mars. But there was a guy down around Washington. You probably know who he is.
Gilbert Levin.
Exactly. I once talked to him on the air, as a matter of fact, via telephone. And he said that the results essentially tend to confirm the presence of at least unicellular life on Mars.
It's, I think, a fair way to put it is that most of the scientists who worked on that program believe there is no sign of life there, even though there are tantalizing and peculiar results that are not fully understood. Mm-hmm. I mean, in a way, the argument against life is that if the signatures that our instruments detected were due to life, the life had to be very, very competent and able to do its stuff in high temperatures and low temperatures, and that looked omnicompetent, too good to be true. What is the prevailing view, and it almost certainly explains some of these results, it's an important finding, is that the surface of Mars, the very surface of Mars, is loaded with things like hydrogen peroxide, oxidants. And you know, you use hydrogen peroxide as a anesthetic, sterilization agent, because it oxidizes like mad. Now, Mars is hit, as we've been saying, by asteroidal fragments, meteorites, many of which are organic. There ought to be lots of asteroidal organic matter on the surface, and Viking found none, not one molecule in a billion. And so there has to be something there that's preferentially destroying the organic molecules, and that's one of the lines of evidence, there are several, that Mars is just sizzling with oxidants. Now, what causes that? And we think we know the answer. The answer is that Mars has a planet-wide ozone hole. So the ultraviolet light from the sun is striking the surface unimpeded, is producing oxidants in the atmosphere like hydrogen peroxide.
So in that sense also a possible vision of our own future.
Or put another way, another cautionary tale about
Yeah.
what dumb things not to do to the Earth
My goodness.
that you can learn by going to other worlds. And by the way, just while we're on that, the 900 degree Fahrenheit surface temperature of Venus, hot enough to melt tin or lead, is produced by a massive carbon dioxide greenhouse effect. And so, in case you ever listen to any radio commentator who says that the greenhouse effect is a hoax, point him to Venus. Now, I want to be very clear on this. I'm not suggesting that there was once a species of Venusians who insisted on driving fuel-inefficient automobiles, and that's what happened. The large amount of CO2 on Venus comes from quite a different cause, but the fact that a large amount of CO2 can devastate a planetary environment is the lesson to be learned from Venus.
Cast our scenario far into the future. I don't know how far we need to go before we have a populated, not merely dome settlements, because they wouldn't be major cities, I don't think, but how far into the future do we go before we have found and migrated to planets that are enough like Earth so that we can really populate them and colonize them?
There are no such planets besides the Earth itself.
We don't know of them yet.
In the solar system. I think we can confidently say that there are none.
We're not going
If there are any planets that we haven't found, they are so far out that they have to be so cold that they don't serve our purpose.
All right.
But there is a prospect. I want to stress that we're not talking about the next few years. We're talking about plausible projections into the next decades and centuries. On that timescale, there does seem to be a prospect to convert, terraform is the phrase that some people use, some planetary environments so that you can live there without heroic survival methods.
You might even do that, say, to Mars itself, could
And
you?
Mars is one possibility.
How do you terraform a planet? What do you do to it?
Well, different planets have different problems. I mean, it's a little like Goldilocks. Some are too hot and some are too cold, and one is just right. And that one, of course, is the Earth. And it's no accident it's just right because we've evolved here, so we're perfectly acclimatized to it if we evolved.
Life tends to develop in places that are supportive of life.
That's one way to put it. Or whichever planet you happen to be adapted to, you think that's the only one that's
To be sure.
congenial for life. But in any case, for Venus, for example, the problem would be to get rid of that big greenhouse effect, and that's very hard to do. For Mars, the problem is that the planet is too cold, and there is no ozone layer to protect against ultraviolet light. And the answer to both of these is to make a bigger atmosphere. And if it's the right constituents, you'll have a greenhouse effect. And if it's the right constituents, you'll block ultraviolet light.
How do you make that bigger atmosphere? Are we back to nuclear weapons again?
No, we are not. Nuclear weapons turn out to be
They have a very-
extremely feeble.
A limited utility.
Limited utility. What you want is an amplifier. When one thing to do is you could carry enormous quantities of the gases you need to Mars from somewhere else or dig it out of the soil. But much better would be if you had a machine that could keep pumping stuff out of Mars into the atmosphere and that made copies of itself so you didn't have to keep delivering and repairing the machines, it would just go by itself. Well, there is such a machine, and it's called a microorganism. And part of the challenge for terraforming Mars is to design microbes that can generate the kind of atmosphere in the right quantities that we would need to make Mars a hospitable
And
environment.
with our new science of genetic engineering, it's quite conceivable that we can do that.
At least by another century or two,
Yeah.
with effective lifting vehicles and fusion power and genetic engineering, it looks possible. Not at all saying guaranteed, but it looks possible
But now
that we could terraform Mars.
The really exciting prospect is far distant space exploration, still within our galaxy, obviously, but it's a very, very large galaxy
Well,
with 400 billion
billion
suns. And finding Earth-like planets that would sustain human life at some far greater distance than Mars is from the Earth. How long will it take? This is merely a matter of projection and speculation, but how long would it take, assuming that there are some such planets out there, and you do assume that, I believe,
let's talk about that first. The first thing to bear in mind is if we're talking about really long time scales, then nowhere in the inner solar system is safe. Because the sun is going to become a red giant, and all sorts of other possibilities, pulsation, erratic pulsation, changes in brightness.
What's the outer limit, by the way, for the tenure of the sun? When does it burn out?
5 billion years, but practically speaking, it's more like 2 billion years before the Earth's oceans boil. Now, that, of course, is the far future, and we have a lot of urgent problems
Well,
that
we've
are
been
higher.
around for 5 billion years on this Earth, so it's only...
Well, not us.
No, but the Earth has been, right?
The Earth has, and life for about 4 billion years.
Yeah.
So that's right. But so in that sense, we're middle-aged.
It's only got 2/7 of its time left.
Yeah, something
in
like
effect.
that. Something like that. That's right. So, and there are other catastrophes that can happen to planets. So again, in terms of taking out an insurance policy, it would be good for humans, if we really are devoted to the continuance of our species, to be in some other places.
Got to stop you.
Okay.
Crucial point, and it's the point that you make in the book. By 2 billion years from now, our species will no longer exist.
The characteristic time for mammalian species to evolve into another one is a few million years. Million, not
So we'll be
billion.
something quite different if we are anything.
Quite right. And nevertheless, we can take preliminary steps. So that's the first point. Second point is there anywhere to go? The outer solar system is absolutely loaded with small worlds. The Kuiper comet belt has trillions, not millions, not billions, trillions of worlds in them.
Where is that built?
It is a big distance away. It starts maybe 10,000 astronomical units away, 10,000 times the Earth distance from the sun. It's a big way away. As far as other planets around other stars, which is clearly some very long-term focus, are there any, and can you get there? Those are the obvious two questions.
The great New England question, can you get there from here, or you can't get there from here? Can you get there from here with the kind of technology we might have 10,000 years from now, or 20,000 years from now?
I mean, already we have 4 ships on their way to the stars.
Yeah.
Pioneers 10 and 11, Voyagers 1 and 2. Now, they're traveling quite slowly. They're not designed for interstellar spacecraft. It's just an accident of trajectory. That
Some of them have
escaped
plaques
Earth.
and other material designed by Carl Sagan.
That's actually right. And the Voyagers have golden phonograph records with information for anybody who might find them in the far distant future.
Including the 4th movement of Beethoven's Ninth, if I remember correctly.
That is correct.
Yeah.
And lots of other stuff, East and West, classical and folk. But our technology is improving very swiftly, and if you make a little extrapolation of the speed of transportation from stagecoach to now, this is the speed in this year, you see the curve is a steeply rising exponential. And without making any commitment as to what the technology is going to be to make us go faster and faster, the most modest extrapolation of these curves suggests that in some centuries, maybe less, but at least in a few centuries, we will be traveling close to the speed of light. And if that's the case, then lots of the galaxy is accessible, and we live in a fantastic time when we are just in the process, for the first time really, of discovering other planets and the breeding grounds of other planets around other stars. We do have one bona fide extraterrestrial solar system with Earth-like planets. And it's a very surprising discovery, quite unexpected. 3 planets at least going around a pulsar called B1257 plus 12.
Where is it?
It's
Is it in our arm of the Milky Way?
It's about 1,500 light years away.
Yeah.
So it's not a near neighbor, but it's just for scale. The distance from where we are to the center of the galaxy is about 25,000 light years.
And our astronomical skills have reached the point where we can determine that they've got 3 Earth-like, possibly Earth-like planets.
It's completely
around that sun.
Yes, it's a completely unexpected discovery.
I thought you can't see planets that far away.
You can see them. You can see them. But what's happened is, this is a pulsar. It's the star.
Sure.
Is a pulsar, a rapidly rotating neutron star that has a kind of beacon, a radio beacon that that sort of sweeps over the Earth very quickly. And if there were planets going around this, there would be slight timing residuals in the period with which the pulsar
they would interfere with
lighthouse
the transmission.
beam. No, it's not that. It affects the rotation rate of the star just a little bit.
Ah, I see.
And because we know the rotation rate to 12 significant figures or something, then if there are planets, there's an absolutely predictable variation in what are called the timing residuals, and you could detect the planets, and they've been found and they've been confirmed, and it's
But did you say 15 million light years away?
1,500.
I'm sorry, 1,500.
100 light years away.
Not 50 million. 1,500 light years away. I guess I made that distortion because it still seems quite a great distance. Even if we can travel at close to the speed of light, what does that mean then?
That's not.
It means 1,500 years to get there.
It does. That's not an objective for us. This is merely an encouragement that planets are a dime a dozen.
And might be much closer to us as well.
In fact, guaranteed.
Guaranteed.
Guaranteed. And the other thing we're finding is that surrounding at least many, probably most, and conceivably all, the nearby very young stars like the Sun is fantastic, in all those cases, fantastic flat disk of gas and dust, exactly what scientists here have predicted you need in order to explain the origin of our planets. Planets are forming in those disks.
Origins of our planets, and also the origin of organic molecules which will ultimately generate life.
In such systems as well. Organic matter is absolutely everywhere. Halley's Comet, we now know, is composed of 25% of organic matter. The moon of Saturn, called Titan, is covered with an orangish cloud layer, and organic matter, including amino acids and nucleotide bases, are raining out of the sky of Titan like manna from heaven.
I looked forward, as of course I always do, to your coming, and I knew that the only problem I would have is that I would mess up on the commercials, because the conversation gets far too fascinating to meet the commercial schedule. So we've got to stop in just an instant. But I want to pose a question which I hope we will turn to directly after those commercials. I think of the discovery of the so-called New World and the settlement of the New World, which was done at a very high cost to the residents of the New World and produced tremendous culture conflict, which indeed led to millions and millions of deaths. You've long been interested in extraterrestrial life, and you've been much involved in mounting the search for extraterrestrial intelligence, SETI, and I know that you're personally convinced that there's likely to be a good deal of life out there elsewhere. Inevitably, if we are going to be settling planets in other solar systems than our own, there would seem to be a high probability that we're going to be doing what the Spaniards and the Dutch and the others did when they came into the Western Hemisphere. We're going to be imposing ourselves upon other, we can't say peoples, but upon other beings, and there might be hell to pay in consequence. One has to ask about the consequences of this sort of migration, which might generate interspecies conflict.
I have a lot to say about that after the break.
And we'll do that right after the break when we return to Carl Sagan, whose new book from which we are drawing tonight is titled Pale Blue Dot, A Vision of the Human Future in Space, and it is published by Random House. Handsomely illustrated, as one would expect, superbly written, very exciting on every page. And we return to this exciting conversation after these words.
From Radio 720 WGN Chicago, you're listening to Extension 720. Once again, your host and moderator, Milton Rosenberg.
And we return to Carl Sagan, his new book, Pale Blue Dot. Before I hit you with a question of extraterrestrial warfare, we've said nothing, I've led you into nothing personal. You and I have known each other for a long time. We've just figured out before that it goes back to it wasn't your first book, but it was the first one that you and I interacted over, and that goes back to the year 1973. I started doing the program in 1972. We missed each other at the University of Chicago. When did you get your doctorate from the university?
1960.
1960, and I arrived there in 65 as a staff member, so we did miss each other on that round. But of course, we've been together many times, including on a few occasions not on the radio. It was a great delight, in fact, to meet with you at the annual meeting of the Committee for the Scientific Investigation of Claims of the Paranormal just this summer in Seattle. You've got so many distinctions. I haven't even gone through all of this stuff, which you do really with most guests. You've been honored by so many significant organizations. They've even named an asteroid for you, which says something very significant about you. You continue, don't you, as professor of astrophysics, or is it professor of astronomy and astrophysics at Cornell, and director of, what's the official name of the laboratory?
The Laboratory for Planetary Studies.
And of course you are as well a founder of the Planetary Society, which is...
It's the largest space interest group in the world.
In the world. And of course you are the author of a book which was the leading science book in English in the history of book publishing in the world, Cosmos, and of course the accompanying television series. And you and your wife, Ann Druyan, have been doing a series which is not yet complete, is it? Isn't there a third volume schedule?
Oh yeah, of which Shadows of Forgotten Ancestors was the first. But we've been detoured on a number of other things, including writing and co-producing a movie version for Warner Brothers
of your novel
of Contact. Right?
Yeah, that's. You just told me before. Jodie Foster will play the young woman.
Yes, she's agreed to do that.
Yeah, that will be fascinating. I thought the novel was superbly done.
Thank you.
Well, let us come back to the universe and our our adventures beyond the pale blue dot.
Okay, so
do we run into extraterrestrials who are going to be unhappy to find us dropping in on them?
Let's go step by step. First off, as far as we've been able to find so far, this solar system is lifeless.
Mm-hmm.
If it were not, if there were even microbial life somewhere, then that would change my view. But in a lifeless solar system, all of the motivations that applied to Christopher Columbus and his colleagues don't apply. There's no gold, there's no spices, there's no slaves to capture and bring back. There are no heathen to convert. And so all of those mainly egregious motives that led to so much pain and suffering don't apply.
So as Woody Guthrie sang, this land is your land, this land is my land, we can say this solar system is your land, this solar system is my land.
Well, I mean, the whole idea of owning a planet seems ludicrous to me.
But
it depends what you mean by my.
Mm-hmm.
But at least
it's where
we
I
can
live.
live. We can.
It's where we live.
That's right.
But beyond the solar system.
Okay. So now, first of all, let's remember beyond the solar system is quite far in our technological future.
But you're estimating 400 to 600 years, aren't you?
Something like that.
Yeah.
But of course, we will in that time have made a very thorough SETI search to see if there is anyone out there. And in SETI, the most likely circumstance by far is that we get a message from someone much more advanced than we.
Mm-hmm.
Not much less, because anybody dumber than us doesn't even have radio, since we've just invented radio. So the scenario is much more to worry about what they'll do to us than what we'll do to them. And as far as the receipt of a radio message goes, that's perfectly safe. The transmitting civilization has no way to know that we even got the message.
We don't have to signal back.
We do. Nothing requires us to answer.
Yeah.
The trouble is that radar and television have already signaled our presence.
Sure.
And so there's a spherical wave expanding out at the speed of light from the Earth that indicates the presence of a rudimentary technical civilization. It contains the television programs of the late 40s. Milton Berle, Howdy Doody, the Army McCarthy hearings, and other signs of high intelligence.
How far have they reached at the moment?
About 45 light years.
Yeah.
So if there's any extraterrestrial civilization within 45 light years, then they have just discovered our presence.
What a thought. They're watching the Army McCarthy hearings.
Yeah, and so as I sometimes say when I'm asked if there are smart beings out there, how come they're not here? Now you know. It's a sign of their intelligence they don't come here. I just mean that as a joke.
Yeah.
So the idea that a very slow and cautious movement of humans out beyond the solar system is going to give us grief is belied by the fact that expanding at the speed of light far ahead of any flotilla of spacecraft from the Earth, is our radio transmission.
Yeah.
So, and that's what's going to dominate our relationships with other beings. if
Now,
you will.
just a while ago I made an attribution, but maybe I should ask you whether I've done it correctly or incorrectly, that you are personally convinced that you've got no hard proof. You've got some things, and you review them in the book, which are suggestive that there is a fair amount of life out there.
Well,
Where is that essentially your conviction at the moment?
My conviction is a very strong term,
Your hunch.
although not as strong as belief. Hunch is much closer.
Yeah.
When I look at the galaxy with so many stars, when I consider the results which I just mentioned about planets now appearing to be a cosmic commonplace, when I bear in mind that the stuff of life is everywhere, even in the cold, dark, diffuse, near vacuum between the stars, when I consider that there are many places which are much older than the Earth and therefore have much more time for evolution to take place, when I reflect that evolution, the process of evolution enunciated by Charles Darwin, has completely general applicability, nothing special about
And
the
do you
Earth.
add to that when you look at the findings, ambiguous though they may be, of the SETI exploration of via radio astronomy?
Come back to that in a second. But when I put all of that together, it seems ludicrous to imagine that we, by great chance, occupy the only inhabited planet. But that's not a proof. That's at best a plausibility argument. And who knows, there may be some terrible unlikelihood in the origin of life, or it might be that civilizations, as soon as they reach technical capability, promptly destroy themselves, as who knows, we might. So you can't be absolutely sure. But if you asked me to guess, if I was a betting man, I would bet on a galaxy filled with life. Now, what about the results of SETI? The project I've been most involved with recently is called META, M-E-T-A, Mega Channel Extraterrestrial Assay. This is a project that has been funded by private membership contributions of a private membership organization, the Planetary Society, mainly $5 and $10 contributions, although there was a significant initial infusion of funds by Steven Spielberg. And the technological guru behind META is Paul Horowitz, professor of physics at Harvard. And recently, Paul and I published a paper in the Astrophysical Journal on our findings. And here is briefly what it's about. We set a set of gates that a signal has to pass through for it to be a genuine extraterrestrial intelligent signal. It has to be very narrow band because natural sources of radiation tend to be very broadband. That is, the frequency has to be very narrow. It, of course, has to not rotate with the Earth. Sources of interference will rotate with the Earth. It has to be much stronger than the occasional glitches in the electronics, and so on. And when we run it through all of those filters and throw away all the events which don't match these criteria, in 5 years of searching, we come up with a handful that really look as if they satisfy these criteria. And the 5 strongest of them all lie in the plane of the Milky Way galaxy, which is where the stars are. So if it was some error, some Air Force AWACS plane or something like that, some near-Earth satellite, we wouldn't get those signals when we're looking at the plane of the Milky Way. So, your heart palpitates when you look at that. But there's a very, very big but. None of these signals repeats. You look back at the same spot in the sky an hour later, a day later, a week, a month, a year, 7 years later, and no repetition. And results that are not reproducible in science are nearly worthless. So while I think about it quite a bit, I certainly cannot claim that we found extraterrestrial intelligence. But these are tantalizing results. Other searchers for extraterrestrial signals have also found similar non-reproducible but very suggestive.
What's a friendly hypothesis about their non-reproducibility?
Here's one. It has to do with interstellar scintillation. This is like the twinkling of the stars. You know, you look at a star and the sudden surge in brightness. It gets bright and then it fades back again. I'm just talking about looking with your eyeball at a star. Well, that also happens in the radio domain. There are interstellar clouds of electrons, and they pass through the line of sight, and they can act as a lens, momentarily focusing the radio waves, so there's a surge in brightness. So imagine there's a steady signal, which is just sub-detectability. And now this electron cloud passes by, temporarily focuses, the distant signal source surges into detectability, and then fades. That would explain it, and the numbers even work out, but then there's the question of how is it that all the sources we find are just in that little range below detectability that can be temporarily brought up into detectability.
A feat of imagination, and obviously this is pure imagination. It's more than conjecture. It's close to fantasy, but it's informed fantasy. If you cast forward a really sizable number of years, what shall I say, 10,000, 20,000, or shall I say 500,000? Give me the largest gap of years between now and then that you feel comfortable talking about, and tell me what you imagine the extension of the human race or the extension of the successor races that evolved from the human race might be.
Right. So, of course, we recognize that the further in the future we try to prognosticate, the more foolish is our prediction, just because humans are fallible. And you look at all the incompetent attempts to predict the future, even a little bit in the future. For example, Kremlinologists failing utterly to predict the fall of the Soviet Union.
Wonderful example, yes.
And you can recognize that you got to be really careful.
Yeah.
Throwing caution to the winds, I would say if we do not destroy ourselves first, which is a real but by no means foregone possibility, then we will be out there. First, we will have temporary visits and then longer sealed habitats, and then terraforming of progressive worlds going further and further into the outer solar system. And then once we're in the Oort comet cloud, we're hopping from comet to comet, kind of like your World War II analogy, but in a less hostile frame of mind. And when we get to the outer Oort cloud, we are halfway to the nearest star. And the nearest stars also probably have Oort clouds, so it wouldn't be much more difficult, instead of hopping to one of our comets, to hop to one of theirs. The two clouds probably interpenetrate at their peripheries. And then there's the obvious thing of reversing the process and hopping down to close to a planet of that other star. And on a time scale of tens of thousands of years, that's roughly how long we've had civilization. So it's by no means the lifetime of our species. I could well imagine stressing how speculative this conclusion is.
Well, no one's going to be around.
To argue with me that I didn't get it right.
No one listening now could disprove it.
Yeah, that's the only comforting thought about it. I imagine that we will be around many stars, and that this spiral arm of the Milky Way may have humans expanding out in fair numbers. Still, I certainly imagine most of us are back here on Earth or in the inner solar system. I imagine we will have to be very cautious and respectful, and bearing in mind that if there are advanced civilizations, we have extremely high motivations to be careful. Remember the Klingon scenario in Star Trek.
I was just about to ask you about Star Trek, as a matter of fact.
In which everybody we meet is exactly at our technological level.
Yeah.
Which is, of course, wrong. The most likely case is they're so far behind us that they pose us no threat, or so far ahead of us that we pose them no threat.
But in at least the current version, or the version now completed with Jean-Luc Picard as the commander of the Starship Enterprise, in that Star Trek series, they encounter cultures, some of which are far advanced over ours and pose great life threats against the human beings and other friendly life forms on the Starship Enterprise.
Yes.
But of course, they are I've never been quite clear what sector or what range within the total universe the Starship Enterprise is examining.
I think they're certainly restricted to this galaxy, but how much of the galaxy, I don't know. My son Nicholas has written 2 episodes of Star Trek. I should ask him.
I didn't know that.
I never thought to inquire how far they've gotten. Yes, well, they would know as well as I where we'll be in 10,000 years. I'll be sure to ask them.
We must pause. We are, of course, late for commercials, and also it is time to open the phone lines. I know lots of people want to get the opportunity to talk with Carl Sagan, and that opportunity is now available to you. The lines are open. The number, of course, 591-7200. The area code is 312, then 591-7200. If you are calling long distance, get your calls in right now. 591-7200, and we'll return after these words.
From Radio 720 WGN Chicago, you're listening to Extension 720. Once again, your host and moderator, Milton Rosenberg.
And our guest tonight is, of course, Carl Sagan, and the new book, which is a wonderful adventure on into the future, and in which you learn painlessly an awful lot of relevant science, is titled Pale Blue Dot, that being the way the Earth looks from far, far away, in a photograph that Carl didn't take himself, not from the... Which space explorer was that?
Voyager 1 from a vantage point well beyond the planet Neptune.
But you sort of commandeered those photographic facilities and got the thing organized so that the picture was taken, and we find it in the book. And it is a wonderful picture. I could go on and on with that, but I'm deflecting myself because we do want to get directly to the phone calls for Carl Sagan. The number 591-7200. At the moment, of course, all the lines are taken, but some will open up as we process some of the calls. So, directly to the first of those callers. Good evening, you're on the air.
Hi, Dr. Sagan. I'm looking forward to your new book.
Thank you.
Are you familiar with a recent book entitled The Millennial Project by Marshall Savage?
I don't think so.
Okay. You're quoted extensively, actually, in the latter part of the book. It's about an 8-point program for inhabiting the galaxy. The point of view that the author takes is that life most probably does not exist anywhere else in the universe. He says that not only is our planet the only source of life in this galaxy, it is probably the only source of life in any galaxy.
Can't imagine how he would know that.
Well, I think that's a very good question. He goes on with about 4 pages of statistical methodology in saying that the odds against life are overwhelmingly improbable. And he quotes you quite extensively as taking the opposite viewpoint.
I do.
I don't know if you could comment on...
I can't, from what you've said, understand what the argument is, and in any case, if you heard Milton and my discussion earlier, you get a sense of why I think life is probably abundant. But I think it's fair to say nobody really knows.
What is, in fact, the balance of opinion among relevant scientists on this?
I think
very
the way to
question?
put it is that the chance of life and intelligence elsewhere is sufficiently high as to justify serious efforts to find it. But that doesn't mean that anybody is sure that it's out there. Just it is such a significant issue about our place in the universe and who we are, and about biology and almost every subject. I mean, especially if we could get messages from advanced civilizations, that it's important to try. Or put in its most cautious way, we do not know enough to exclude the possibility, and therefore we should look.
One of the most exciting lectures I ever heard in my life was within the first week after I arrived at Yale University as a new assistant professor with PhD hot in hand. And Harlow Shapley was giving a lecture at the university, and it was on just this subject.
Yeah, he was a very good early popularizer of the subject.
Here is the next caller. Good evening, you're on the air.
Good evening to you.
Yes, sir.
Dr. Sagan, it's a great honor. I would like to ask you if you could summarize your opinion of Richard Hoagland and his particular beliefs, of which you're quite familiar, I'm sure, and whether you think he has anything to stand on or whether he is completely out in left field.
Okay. So let me first, for the audience, say what these contentions are and then say what I think about it.
Mm-hmm.
The contention is that there is, in a place on Mars called Cydonia, a giant stone face, a few kilometers across at the base, maybe a kilometer high, staring up to the sky, not a very friendly face, maybe a helmet on it. And the idea is that this is monumental sculpture dating back so far that as to reach a time when humans certainly didn't have technology, and therefore our whole sense of human evolution is wrong. And then there are very enthusiastic, palpitating other conclusions about religion, about craters in the solar system being made by a past nuclear war, and so on. What is the actual reality here? I think a good way to look at this is to note that there is an eggplant that looks exactly like former President Richard Nixon. Now, how can we understand this? Is this aliens meddling in eggplant genetics? Is this a plot by the Republican Party to imprint President Nixon's face on our memories? Or is it that if you have 1 million different eggplants, all of which have roughly the shape of a human head, every now and then there's going to be one that looks familiar to us, who are very good at recognizing things that look like human faces, even spuriously? I think it's clearly the latter. The so-called face in Cydonia, which isn't all that perfect a face, especially if you look at the almost unilluminated half of it, is a rough, blocky mesa sitting among hundreds of other blocky mesas, each of which has a different look, sculpted by ancient mud flows and windblown sand and so on. If you ask me to guess, I would guess that this is merely exactly the same kind of thing as the eggplant. But I don't object to looking more closely. I would want to do that. And so the next time we have a high-resolution camera on a Mars orbiter, in the list of the 100 or so things we ought to do, by all means, let's look at this thing and see if there's anything interesting at high resolution.
What comes to mind is the dialogue between Hamlet and Polonius. Methinks yon cloud is shaped very like a camel. I, my lord, 'tis backed like a camel.
Yes,
And
and
so
isn't there
on.
something about a handsaw coming up in that? Or maybe I'm
In
mistaken.
another part of the play.
Yeah.
591-7200 is the number. One line is available at the moment, and we shall return right after we pause for these words.
From Radio 720 WGN Chicago, you're listening to Extension 720. Once again, your host and moderator, Milton Rosenberg.
And directly back to Carl Sagan. All I want to make clear once again, for those who may have tuned in late, is that his new book is just recently out. It's titled Pale Blue Dot, A Vision of the Human Future in Space. Superbly written, as one would, of course, expect. And by the way, superbly illustrated. I didn't know there were so many painters who were doing so much extraterrestrial representation.
Yeah, there's a whole genre of astronomical art, and some of the best exponents of that were kind enough to contribute exquisitely detailed paintings.
Superb stuff. Reminds me of some of the work of, what was his name? Way
Chesley
back.
Bonestell.
Bonestell.
Right.
Yeah.
Who is the sort of patron saint of
Is he?
astronomical art?
He should be, yeah. This book, Pale Blue Dot, is published by Random House. Our number, 591-7200, and you are on the air. Good evening.
Yes, hello, Dr. Sagan.
Hi.
I'm also looking forward to reading your book. I hope to get it as a Christmas present.
Thank you. Good luck.
Oh, thank you. Actually, I was wondering what your opinion is as far as the moon Europa, as far as harboring life.
Well, Europa is very interesting. It's one of the 4 big or Galilean satellites of Jupiter, and there are theoretical reasons to believe that it may have an underground ocean of liquid water.
That's what I heard.
Now, we're not sure of that, and in fact, exactly a year from now, when the Galileo spacecraft is inserted into orbit around Jupiter, we will start having a much better idea whether that's the case or not. But if there is an underground ocean, that doesn't, of course, mean that it's necessarily filled with swimming creatures. But it's a very interesting question. If it's warm enough for liquid water, and there's a lot of liquid water there, and there's some source of energy, who knows? It's one of the many fascinating prospects that face us in the near-term exploration of the solar system.
Sir, we thank you for the call.
Well, thank you.
Glad to have heard from you.
All right.
There are now a few lines available at last. If you've been trying to reach us, quickly make another attempt, and somebody will get through on 591-7200. 591-7200, and you are on the air. Good evening.
Good evening, Dr. Sagan. It's really an honor to be speaking with you.
Thank you.
And I was just wondering, the public desire and governmental desire for manned space exploration has really waned in recent years, and I was wondering what you see as the prospect of getting the public and getting the government back into really putting forth a lot of effort to getting man back out and getting to the places that you've been discussing all evening.
Thank you. I'm really glad you asked that question. It was a thing I meant to talk about. So let me say a few words on that. First off, I personally have trouble with this word manned, because after all there are women astronauts, and manned and womaned is awkward. For a while I was thinking of using the word crewed, C-R-E-W-E-D, but it lends itself to misunderstanding in spoken speech. You know, this was a crewed mission. And so what I've sort of gotten down to is to talk about human missions as opposed to robotic missions. But every now and then the unself-conscious sexism of my youth, when the phrase man came up, slips through. So having said that, now let me try to address your question.
Mm-hmm.
The Apollo program was a glorious program, and has deep historical significance. And, you know, 1,000 years from now, when nobody will know what GATT stands for, or who the Speaker of the House in the late 20th century was, they will remember, of course, Apollo, and likewise the robotic missions that it spawned. But Apollo was not about science, was not about exploration. It was about the nuclear arms race, beat the Russians, nuclear intimidation, muscling other nations. And the United States won that race to the moon. And when we won it, the political purpose was served. And then we stopped. And the clearest indication of that is that the last human to step on the moon was the first scientist to step on the moon. As soon as the scientist was there, clearly we were wasting our money. What are we doing with a scientist? Cancel the funds. And the lesson from that is that human spaceflight, because it's expensive and also because it risks lives, requires a overarching political or historical justification. You want people in both political parties and both houses of Congress and across the boards, in a country in which there are other very pressing human needs that need money. You want to have such a space program, you better have a good reason for it. Now, what's happened since Apollo is that the human space program has narrowed its focus into shuttle missions. Typical shuttle mission, there's 5 or 6 or 7 people who go up in a tin can 200 miles up in the sky and launch a communications satellite, which could just as well have been launched by an unmanned booster and much cheaper. And then the tomato plants didn't grow, or the newts are reproducing nicely, thank you. And then NASA calls that exploration. That's not exploration, that's bus driving. And 200 miles, I mean, it's more than 200 miles from here to, I don't know, Detroit. And suppose you drove back and forth to Detroit dozens of times and called it exploration. People would look at you funny.
But it's 200 miles upward.
Yeah, upward, sideways, it's just 200 miles. It's not exploring, it's not going to a new place, a new world. Whereas, if NASA had been able to explore near-Earth asteroids or go to the far side of the moon or go to Mars, then public support, I believe, would have been sustained at a very high level. It's not NASA's fault because there are many boundary conditions put on it, including all sorts of pork barrel politics in Congress and a kind of failure of nerve in the administration.
Is it conceivable to you, Carl, that we could do something to plug the hole in the ozone via space activity, and would that be a goad that might get us back up there again?
Well, first of all, that would be very, very little up in the up there.
Yes,
because
how high up is that?
Well, stratosphere is 10 kilometers up or something like that. And also, one worries very much about, do we know what we're doing? Are the side effects, is the cure worse than the disease? The right cure of the depletion of the ozone layer is to stop producing the stuff that makes the ozone layer.
To be sure.
And because of the Montreal Protocol, all the industrial nations have agreed to do that, and CFCs are going to be almost entirely phased out in another couple of years. So we have another non-space solution to that.
Well, then what's the next goad that we can expect to stir us or goose us up into serious space exploration
The
again?
Clinton-Gore administration likes the idea that international cooperation, especially the United States and Russia, is such a goad. And it's not a dumb idea. I mean, the Russians have fantastic space capability that we don't have, and vice versa. It's kind of a marriage made in heaven, but it's been remarkably difficult to consummate. And just in the last few years, mainly at the impetus of Vice President Gore and the NASA Administrator Dan Golden, it's beginning to happen. And that is the way to get this done, because you do things with the Russians, with the Europeans, the Japanese. You share costs. You draw upon their enormous technical and intellectual capability, and now you can do things the United States could never do on its own. It's important to bear that in mind. We're not talking about a huge amount of money. The total NASA budget is under $14 billion compared to the defense budget, which, if we include hidden costs, is well over $300 billion.
We thought we were going to have a peace dividend, and the defense budget would be significantly decreased, and it could be deflected towards some such operations as these, as well as various other social programs and social problems. But apparently defense isn't taking as much of a hit as we thought it would.
No, well, it's always easy to find enemies, real and imagined, and anyone who says let's lower the defense budget, oh, you're not interested in the security of the United States, and we never have a serious debate on these issues. It's always politicians desperately afraid of being called unpatriotic when they recognize, if they were to, that national security doesn't just mean weapons. It means a whole lot of other things, education and health and caring for the poorest among us.
Yet you are convinced that within fairly short time we will be once again heading out from the pale blue dot.
Yes, and if the United States does not play a major role, then other countries
Somebody
will.
else will.
But the human species is clearly going out because the technology is getting cheaper, the reasons for doing it are becoming clearer, and it's certainly going to happen.
Indulge me for a moment on something that I wanted to ask you before. And then we go to commercials for a last round, and then right back to the phones on 591-7200. Speculations about the direction that post-human evolution might take are fascinating. What did you say before? The average mammalian species might run for as long as...
A few million years.
A few million years, and then we'll turn into something else. By the 2 million years when we've sort of got to get off this planet, if we're going to continue whatever the successor race may be. Again, this is pure speculation. No one is going to be around to check you out on this or to call you into question on this. But where are we going in evolutionary terms? Is there any way of thinking about that? I know you've got a lot of biological background and you know a lot of biologists and exobiologists. What can we think about?
I don't think it's possible to do that. It's very subtle and tricky. And
can we assume we're going to get smarter than we are now? Bigger brain cases, bigger brains.
You would certainly think that other things being equal, it's better to be smart than to be stupid.
Sure.
At least until the invention of nuclear weapons, when maybe it goes the other way. And you see what I mean by being tricky. It's absolutely unpredictable, and even retrospectively, when we look at the record of evolution of other species or of our own, it's very hard to see. Oh, this is the way it has to go, and then dig it up, and sure enough, there's the fossil. Very often, completely unexpected directions and weird things that you didn't figure, and huge, sudden rushes in evolutionary direction, and then long periods of stasis, so-called punctuated equilibrium.
So we can't even assume that 50 million years from now human beings will look the way human beings now do?
I think it's very unlikely.
They'll still be quadrupeds, won't they? They'll still be erect
we're,
on two
we're-
legs.
Yeah, we're bipeds.
Well, I mean, quadrupeds who are bipedal in locomotion,
Right.
exactly.
But who knows? I mean, on a much swifter time scale, Milton, is prosthesis, is human-machine marriages. And, we do it with eyeglasses and hearing aids and heart valves and all sorts of things like that today. But you can imagine all sorts of things, including replaceable modules in the brain and things of that sort. And on the time scale you're talking about, I think that's likely to dominate any of the biological evolutionary stuff.
It would be sort of nice to hang around for the next billion years, wouldn't it?
Yeah,
To see
the
what
worst part
happens.
of dying is not to find out how it all
Exactly
comes
so.
out.
But I know how the next 3 minutes will come out. We'll take care of some messages and then right back to the phones on 591-7200.
From Radio 720 WGN Chicago, you're listening to Extension 720. Once again, your host and moderator, Milton Rosenberg.
And quickly in the small remaining time, back to the phones. You are on the air.
Monotone.
Hello.
Hi, Dr. Rosenberg?
Yes, ma'am.
Hi, my uncle Scott Sagan was once on your show.
Yes. Yes,
I
indeed.
don't-
I remember him.
Yeah, I had a question for Dr. Sagan. I wondered how worthy you thought the Biosphere 2 experiment was.
Sure. Yeah, are you a Sagan also?
Yes, I am.
What's your name?
Margaret?
Hi,
And-
Margaret. How you doing?
Good.
Now, as far as I know, Scott and I are not related. We did try to figure this
No,
out.
I don't think you are.
But
He was
but
involved in
He worked for the Joint Chiefs of Staff.
Joint Chiefs,
and, he has a very important, very good book on risk assessment for nuclear weapons.
But
and
you
other
are
things.
related to the other Sagan I know, Bruce Sagan. Here
Yes,
in town.
that's absolutely true.
Yeah.
Anyway, as far as give him my best, Margaret. As far as Biosphere 2 goes, well, this is an attempt at a closed ecological system in a place with the wonderful name of Miracle, Arizona, and it wasn't closed. Gases were exchanged, and people went in and out, and they had a wide variety of problems. And because there are so many uncontrolled variables, it cannot be said to be a first-rate science experiment. Now it looks as if the scientists are more in charge and there may be real science being done. But with respect to what we were talking about before, about closed ecological systems on other planets with humans living in them, clearly this is an early forerunner of that sort of thing.
Our thanks to the caller, 591-7200. You are on the air. Good evening.
Good evening.
Yes, sir.
Thank you for taking my call. To build on the last gentleman that called you and your remarks thereon, I heard that there was a program that the government was paying for and had initiated to monitor extraterrestrial signals. That was just fairly recently terminated. Is that so? Or do you know
That
anything
is
about
true. Oh, it's certainly true.
Mm-hmm.
The project was called HRMS High Resolution Microwave Survey. It began on October 12th, 1992, and was canceled exactly 1 year later. The argument of the principal opponent, Senator Bryan of Nevada, was that we didn't know that there was extraterrestrial intelligence, and also that this is very expensive. How expensive was it? It would have cost one attack helicopter a year.
Oh, my. Was there ever a glimmer, was there ever any scintillation of a signal that might have been construed as an intelligent message?
No, but they had bugs, and the startup time is long. But there's a very good coda to this, and that is that they have the same people have raised private money, and this project, now called Project Phoenix, is going to go on the air, at least for a short period of time, early next year from Australia.
I see.
Sir, we thank you for the call.
Thank you.
And let us go quickly to another. You are on the air. Good evening.
Hello.
Yes, sir.
Oh, Dr. Sagan.
Hi.
I both study and teach astronomy at the University of Kentucky, and I've been surprised and dismayed at the
Where are you calling from, sir?
I'm calling actually from a truck stop in Indiana. I was listening to your show north of Louisville.
All right.
Great.
And I'm still enthusiastic about taking on a teaching career, but I find that some of the problems seem almost insurmountable. We're talking about going to the stars, but people know so very little about science here, it seems.
Well, there's no question that so-called scientific illiteracy is rampant, and in a recent survey, 25% of American adults did not know that the Earth went around the sun and took a year to do it, just to give some calibration. And this is extremely foolish and dangerous. We've arranged a society that is based on science and technology, and at the same time arrange things that almost nobody understands science and technology. And, you know, it's clear that it's a prescription of disaster. This mixture of ignorance and power is going to blow up in our face sooner or later. And especially in a democracy where the people are supposed to control what the government does. And if you look at all the things concerning science and technology the government has to decide on, who is going to make these decisions if we cannot figure out what we're talking about?
People don't understand science and technology. On a compensatory basis, do they understand something else any better?
Well, I think the general level of education... Thomas Jefferson made a very profound remark in which he said that any society that imagines it can be both ignorant and free imagines what never was and what never will be.
And you agree, then, with me, because I've been raging about it for years, that in general the quality and the level of education and sophistication is declining precipitously in this society across all areas. Science, certainly, also general literacy, also numeracy, also any concern with and investment in some of the persisting significant issues of value that matter to human beings.
And in part this is because of the free market system and the profit motive, because if the idea is to go to the lowest common denominator, then you do not spend time on the more difficult issue of raising people's sights. And what I found from the Cosmos television series and many other ways is that people long to know about science and all the other things you were talking about. They recognize they have to understand that to manage their own future, that it's a tool for their children and grandchildren, and the society simply isn't delivering what the people need and what the people want.
And, you know, to strike a small parochial and self-referential note, that's the reason why a program like this works as well as it does and gets a sizable audience.
I completely
People
agree.
beat a path to your door because you're trying to do some intelligent talk about significant things.
And if you ever talk to first graders, you get a very hopeful sense of what their interests and capabilities might be if they didn't have it beaten out of them by 12th grade.
Our thanks to the caller. Carl, we have about a minute and a half left. Speaking of ultimate questions of value and treading on the barriers of philosophical inquiry and concern, what has your whole life's work done in terms of shaping your values, and what has the further inquiry represented in the new book led you to in terms of ultimate issues?
Well, you know, ultimate's a big word. I would say one thing that I've learned is how little we know, is how the frontiers of science, you can think of us as standing on a little island of knowledge, surrounded by an enormous ocean of ignorance. And every year we sort of eke out just a little more land and prevent the ocean of ignorance from swamping us. And that's all that stands between us and drowning. And I think it's for a technical civilization, agricultural economy, where not just entertainment, but the difference between life and death, look at medicine, for example, is knowledge. We have to be much more serious about knowledge.
So we'd better get busy not only getting out into space or venturing out into space, but also venturing into intelligence itself.
That's right, and the two go hand in hand.
Of course they do. It's been a delight having you here once again, as of course I knew it would be. The new book by Carl Sagan, Pale Blue Dot, A Vision of the Human Future in Space, is published by Random House. So we've done it again.
Thank you, Milton. It's a pleasure as always.